Now, there is a one more topic for the module 4, the operator precedence parser. We studied in module 4, one is top-down parsing, second one is bottom-up parsing. There is a third technique is operator precedence parsing. You know how to do it for the top-down parsing by using from root to leaf, bottom-up parsing from the leaf to root, and the third one is operator precedence parsing. Then as the name indicates, it mainly depends on its operator. If the grammar have operator, then how can I get the relationship between the two operator? Using that I can construct my parse tree, or I can also construct operator's precedence table. For that we will studied in this topic, operator precedence parser. And what is the type of operator precedence parser can grammar can accept? See, in the operator precedence parser can apply depend only to operator grammar. What do you mean by operator grammar? Then operator grammar is a small but an important class of grammar. We may have an efficient operator precedence parser. Means it is also use the concept of shift reduce parser for an operator grammar. Okay, let me read the definition of operator grammar. An operator grammar have no production rule can have means the operator grammar contains these two conditions. No production rule have epsilon at the right hand side. That's any of the grammar does not contain epsilon. Then two adjacent non-terminal at the right side. That these two condition is not there in our operator grammar. The two adjacent non-terminal at the right side. For example, you can consider E derives AB. What is there? In the right hand side, I have a two non-terminal. There is no operator between these, and this production is not an operator grammar. See, A derives A and B derives B. There is no operator between these. Then I can't take this as an operator grammar. Okay, let's take the next example. E derives E OE. There are three adjacent non-terminal, but there is no operator. And E derives ID. There is no operator. But now I have only operator. There is no operands. And this is also not an operator grammar. Okay, let's move on to the next one. Okay, E derives E plus E. See, I have an operator between the two operands. Then it is and belongs to E derives E star E. E or ID, and this is called as an operator grammar. If the grammar has there is no epsilon and there is two adjacent non-terminal on the right hand side, if these two conditions are satisfied, then it is called as an operator grammar. The always should be considered for this operator grammar only. Now I have an operator grammar and I have an input. Assume for that grammar I have ID plus ID star ID. Then how can I make a relationship between those input ID plus ID star ID? Then I have to write a relationship between what is the relationship between ID and plus, what's the relationship between plus and ID and star, like that. If you want to write a relationship between that my input, then I have to use these three constraints to write the precedence operator precedence relation. Operator precedence relation parsing. We define a three disjoint precedence relation between a certain pair of terminals. Okay, always should be get a pair of terminals. Only I want to write a relationship between. How to write the relationship? The relationship can be by using of less than symbol, equal symbol, and greater than symbol. See, a less than dot. This is a symbol. A less than dot means if you are there comparing between A and B is a terminal symbol. If you get less than symbol means B has a highest precedence than A. For example, plus A is plus B is star. Always the star has highest precedence. Then always should be write plus and star between less than symbol. Plus and star. The star is in the right hand side. For that I am writing the less than symbol. If in case A equal to B, for example, plus and plus both are same precedence, then how can I write? Both are the same precedence, because of that I am writing equal as the same precedence as A. B has the same precedence as A. Then A is greater than B. B has a lower precedence than A, or A has a higher precedence than B. That means star and plus. The star is left hand side, then star has highest precedence, Because of that, I am writing a greater than symbol for that one. Using these three relations, we can write any type of operator for the relation table. The determination of the correct precedence relation between the terminals are based on the traditional notation of associativity and precedence of operator. We are not considered as of now unary minus because there is a problem in that while constructing the table. But lexicon analyzer will solve out that unary minus and binary minus. But as of the problem solving, we are not considered unary minus. We can use the same concept of associativity and precedence for whatever learned that previous semester. Okay, now how to read the table? The using operator precedence relations. Then the intention of the precedence relation is to find the handle of a right sentential form. What is the use of this precedence relation? For example, I have a ID plus ID star ID. I have to use shift and reduce operation. I want to find out the last one as the root symbol because it is working with respect to bottom of parsing. All body of the production should be replacing with head of the production. Finally, I want to get a root symbol. For that, I have to find a handle. To find the handle, each step I am replacing the body of the production. How can we replace it? Then each step we replacing will get right sentential form. For that purpose, we are using this operator precedence relation. Okay, then if the less than making the left hand and equal appearing the interior of the handle and greater than making the right hand. Always there is a handle is between less than dot, greater than dot. Between the less than and greater than, what is the terminal or it can any of the symbol that can has hand that it can be reduced by your head of the production. Always handle is between less than and greater than symbol. Okay, in our input dollar $A1 A2 dash dash A1, then we can insert the precedence relation between the pairs of the terminals. For example, there is an input, then I want to insert the relationship between dollar and A1. Assume dollar A1 should be plus. Then how to write precedence relation? Dollar and plus. Always the plus have highest precedence compared to the dollar. Then we should write less than symbol between that. Like that, first you can write it. Okay, let me take one example using operator precedence relation. For example, like E derives E plus E, E minus E, E star E, E division E, and E exponential E, E parenthesis is minus E ID. Okay, as of now, I don't take all the operator. I will take my input. Okay, the partial operator precedence table. Why it is called partial precedence table? I didn't consider all the operator. Okay, my input is then the input string is ID plus ID star ID. I am writing the precedence table only for this input. For this input contain identifier plus and star. I don't want to consider remaining division, minus and exponential and parentheses, all those things. That later I will show the big table. It contains all the operator. To understand, I will take a simple example. How can I construct my operator precedence table? Okay, this is called operator precedence table. You have to make a row and column for what are all the terminals my input. Input terminals you should take only for ID plus star and there is no bracket in your input. Only I'm showing that bracket I'm writing. If this bracket is also there, then your precedence relationship will change. Okay, now assume only my input is ID plus ID star ID only. For that, I take an ID plus star dollar. You can write any order. ID plus star dollar. The always should be insert dollar between both beginning of your input string and end of your input string to make it as a relation for that one. Okay, now I am taking this is my row and column. Now I have to start the comparison between these things. See, now I have to write the relationship between using less than symbol, greater than symbol, or equal symbol. Let me start how to write it. ID and ID. Then always there is no relationship between ID and ID because I can't possible to compare A is greater than B is greater than, or C is greater than, D is greater than, or Z is greater than Y. I can't write any of the relationship between any identifier. Then ID and ID is not possible to compare. You leave that space as an empty space. Then next move on to ID and plus. Always identifier as highest precedence compared to the plus. the relation between associative in the precedence over to identify as highest precedence than the plus. Because of that, I am writing the greater than symbol of this side. I am writing this greater than symbol for ID of a highest loss. I am comparing ID and star. I am comparing ID and star. Again, ID has a highest precedence. I am writing the greater than symbol. ID and dollar. Again, ID has a greater than symbol. Okay, now compare the next row. Plus and ID. Compare with plus and ID. ID has highest precedence. Then I am writing the less than symbol. Plus and plus. Both are the same precedence, but I have to apply a left associativity between the plus and plus. Because of that, I am writing a greater than symbol because the left associativity. In the question, if you give right associativity, then right associativity for that one. Or if you not mention anything, then you can use equal also. Then plus and star. Star has highest precedence. I am writing the less than symbol. And plus and dollar. Then plus and dollar. Plus has highest precedence compared to the end of your input string. Then write the greater than symbol. Then star and ID. Third line. Star and ID. ID have highest precedence. You write less than. Star and plus. Star has highest precedence than plus. You write greater than symbol. Star and star. Same concept, both are same precedence but left associativity. I am writing greater than symbol. And star and dollar. You write greater than symbol. Now I have to compare with the dollar with ID. Always you compare with the dollar with any of the terminal, it should be less than only. Dollar with ID less than, dollar with plus less than, and dollar and star less than. If there is no relationship between dollar and dollar, you put empty for that box. Okay, this is called operator precedence relation. Using this operator precedence relation, you can write the relationship between the input string ID plus ID star ID. Okay, now I am inserting the relation between this input. Before that, you should be append dollar and dollar at the end. Okay, now start. You should be write first dollar, then should first write ID. What is the relation between dollar and ID? You can see the table. Dollar and ID, there is a relationship between is less than. Because of that, I am inserting dollar and ID is less than symbol. Now I have to compare with ID with plus. What is the relationship between ID with plus? ID with plus. ID have highest precedence. Then I am writing the relationship is greater than between. Like that, I have to compare each and every input symbol with the next symbol. Like I have to compare with ID with star. ID with star what? ID with star is greater than. See ID with star. I am writing greater than symbol. Now I compare star and ID. What is star and ID? ID has highest precedence. Now again compare ID with dollar. ID with dollar. ID has highest precedence. I am writing greater than symbol. Okay, this is called precedence relation inserted between those all the terminal. Now I have to reduce. Now I have to find out the handle of all those things. I'm applying a shift reduce parser to find out the root symbol of this. Finally, I want to get the E. Then how can I apply shift reduce parser for these relation? How can I apply shift reduce parser? Let me see the next one. To apply to find the handles, then what are the steps? I want to scan my input from left to end until the first greater than symbol is encountered. That means I want to scan my input symbol. This is my input relation. I wrote it. Like now I have to scan my input symbol till I want to get the first greater than symbol. Wherever you get the first greater than symbol, you should be again should be scanned backwards towards to get the first less than symbol or equal symbol. See the second step. Then scan backward to the left over any equal or until a less than is encountered. When you get less than symbol, that is the third step. The handle contains everything to left of the first greater than and to the right of the less than is encountered. That meaning is steps. Okay, now I am scanning from these to this. When I get greater than symbol, the second step is you should be scan backwards to get the first handle. After I get this first handle, the less than symbol, then I have to get the handle. The handle is always between the greater than and less than. What is the handle I got? ID. Then you have a grammar where ID will be replacing with E. See, ID will be replacing with E. Then for that, I am pop up from ID. then I'm replacing with capital letter E. See, now I didn't show here the capital letter E, I'm showing here ID will be replacing with E. Okay, just see, ID will be replacing with E, but here it contains only the operator. Because of that I didn't write. ID will be replacing with E. The same thing I am doing for the continuation. My input again scan towards the right, then where I got the right greater than symbol, again to scan towards for the left hand. Again now I got an handle between ID and ID. Then ID and ID will be replacing with E. ID will be replacing with E, the action. The next ID will be replacing with E. I'm showing here. I'm writing the same only less than operator between the, that is write it. Okay, now you can also write this line on. The next I'm scanning towards that ID. Then again I'll get handle between greater than and less than. That is replacing with ID. Third one, E derives ID. Because of that I'm writing dollar $E plus E star E. Okay, now I got dollar $E plus E star E. I got it. That ID will be replacing with E. Okay, now what are the next thing? Okay, now I have to write. I have to reduce these things. Dollar $E plus E star I. Okay, for example, in that input I didn't show. If you have any doubt, see, you have to remove all those E, E, E. Only take only the operator. Now you can write the new relationship between that operator. And how to write? You can compare dollar and plus. If you remove E, what is the relationship between this? Dollar and plus, the relationship is less than. Again you write plus. Plus and dollar. You remove I. What is the relationship between plus and dollar? Plus and dollar relationship is less than. The third one. Again star and dollar. Star has highest precedence. Because of that I am getting greater than. Then how to get this one? With this relation between the operator plus and star from using these input. After reducing all ID with E, you got this right sentential form is this one. Okay, here you removed all the non-terminal, you take only dollar plus and star. Now apply a precedence relation between dollar plus and star dollar. You got this one. Okay, now again start your reduction. See, there is an handle between, here is star, open less than and greater than, there is a star. Star is between which production? The star is between E derives E star E. Because of that, that means the star is there between E derives E star E. That is my handle. That I have to pop up from my string, that reduce by being and then the whole thing should be pop up. The remaining will be left with only the plus. Now I can write the next relation, plus and dollar. I have removed from all those things that the next relation plus and dollar. Plus and dollar, plus has highest precedence. Now you can insert these things. Again dollar. Now I got to scan from left to right. I got less than plus greater than. There is a handle between E derives E plus E. Again E derives E plus E. I have to reduce by that root symbol E. Now finally I got dollar is dollar E E. Now the whole thing should be removed. The final is dollar dollar. Dollar dollar is your accepting condition. Dollar dollar you reach, that means you are accepting for you reached your root symbol. See, dollar E dollar. Okay, in this way I have to parse my input string by applying a shift and reduce action to find the root symbol. Okay, now how I'm applying this method? This method can be applied by an algorithm. In the exam, you can ask also write an algorithm for operator precedence parsing algorithm. When should be shift, when should be reduce, and when should be accept, when we get an error. Okay, by using of all those four config, now I am write an algorithm for operator precedence parsing. Okay, because I am showing here operator precedence parsing the stack input action. You can write this format or you can follow this format. Whichever you are comfortable, you can show that format. The term is I have to show shift reduce parsing using operator precedence table. I'm showing line by line for that with respect to operator. To write this, see, I'm writing this algorithm. The input string is identified by W. W is your input string ended with dollar. The initial stack is also contained dollar. This is the constant. And a table holds the precedence relation between the certain terminal. See, say I will show your stack operation. The stack contains dollar. input is W ended with dollar, and table is contains terminal symbol relationship. This is the constraint. Okay, now I have to start my doing. Okay, I have to scan my input dollar and ID. What is the relationship between dollar and ID? You can check it. Dollar and ID. The dollar and ID relationship is less than. As an algorithm says, if it is less than symbol, shift your input symbol into stack. See, I am shifting ID into the stack. The next condition, ID and plus. See the relationship between ID and plus. ID and plus is the relationship is greater than symbol. If it is greater than, I have to apply a function is reduce ID by E. Okay, now I am pop up for ID from the top of the stack, replacing non-terminal E. But I didn't show non-terminal here because only this is with respect to operator. Because of that, I only pop up ID. I didn't push on E only. Okay, now there is a relationship between dollar and plus. Dollar and plus. What is the relationship between dollar and plus? Less than symbol. Because of less than symbol, you will shift into stack. Plus is shifting. Now again compare plus and ID. Plus and ID is less than symbol. Because of less than, again your shift. Now compare ID and star. What is an ID and star? ID and star is greater than symbol. Now you can reduce erase ID. Now I'm pop up from ID from the stack. The remaining with plus. Now I have a plus and star. Star as highest precedence is less than. Then you should shift star also. Again compare star and ID. Star and ID less than I am doing. Okay, these three actually error. Only should be write only the dollar in the table. Okay, don't write this because I already shift ID. Now I have to compare with ID with dollar. Okay, don't take this one. This step actually come here. ID with dollar is greater than symbol. Then applying this will be move on to the action part. Then replacing ID with E. Okay, now ID will be replacing with E. Only I'll get star. Now I compare again star and dollar. Star and dollar. It's a greater than symbol. Again reduce E, reduce E star E. Star is also pop up. Now I got only the plus. We compare plus and dollar. Plus and dollar. Plus and dollar. Plus has highest precedence. Reduce E, reduce E plus E. Now I got dollar. Here I got dollar, and this is accepting condition. Okay, this is for how shift reduce parsing can happen by using this algorithm. Okay, this is an algorithm we are using. See, set P to the point the first symbol of W dollar. Repeat forever. If dollar is on the top of the stack, for example, dollar is on the top of the stack, and P points to the dollar. P can be ID now. Then return else. Let A be the top of the terminal symbol on the stack and let B be the symbol pointed by the P. Assume there is a dollar and there is an ID. Then how can be comparison between these two things? If A is less than B or A is equal to B, then you have to apply what action? Shift action. Push B onto the stack. Whatever the input, that should be pushed onto the stack and advance P to the next input symbol. Now advancing input pointer to the next symbol if it is less than or equal. If in case then else if the comparison between A and B is greater than, then apply reduce. Repeat the pop stack from until the top of the stack terminal should be replaced by related by less than to the terminal of the most recently popped. We should be popped till I want to get the less than symbol. If it is not their relationship between less than or greater than or equal, then you should be always should be called error. That means in the exam you will get any one of the input string, write down the precedence relation, you have to show the relation and you should be write this input action. In the 6 marks question, write the relation table and shift this action by using operator precedence parsing. Okay, sometimes you will get this is some example. How can you write the relationship between the two operator? Okay, the how to create a operator precedence relation between then theta 1, theta 2. Assume any two operator, either it can be plus, either it can be minus. Anything. We use associativity and precedence relation among the operator. If operator T1 has highest precedence than operator T2, how to write? T1 is greater than T2, or you can write T2 is less than T1. Both are same representation but have T2 as highest precedence. Okay, now if operator T1 and operator T2 have equal precedence, but if you have a left associativity, you can write, for example, T1 is greater than T2 or T2 is greater than T1. right? Associativity, you should be right like this. Okay, some of the operator you should be right. Always should be any operator identifier as a highest precedency, less than. Identifier is distance, greater than symbol. Then compared to identifier, open parenthesis as a highest precedence, and compared to this is for open parenthesis of highest precedence, then open parenthesis with ID. See, wherever the I open with ID have I, because in the inner value of the bracket I have to compute it first. Because of that, open with ID have highest precedence. And ID with close. For example, before closing there is an identifier. I have to find out identifier value first one. Because of that, this identifier only have highest precedence, that one. Again, open and ID I written, and anything with the dollar, always the identifier has highest precedence, and dollar with ID, then ID have highest precedence. This is the common representation. Okay, now open and close, there is an equal relationship between dollar and open. See, dollar and open, the always the now open has highest precedence. ID and close, before closing the inner value should be computed because of ID have highest precedence, and close and dollar, close as highest precedence, open and open left associativity or right associative, because inner value should be computed first, then id and this dollar, id id and dollar, this one close and close, the inner close should be computed first. It is some example. Okay, now I move on to the big example for the first one. Here you consider all the operator. Now I have to fill the table. So the operator precedence table for all, plus, minus, star, division, exponential, open, close, dollar. You have to trace by yourself and write down the table. Don't copy, just make a blank of all those is compared. Plus and plus, both are left associative, put left. Plus and minus, both are same associative, apply left associative. Plus and star, I will left because the star is highest precedence. Plus and division, division has highest precedence. Plus and exponential of highest precedence. Plus and id have a highest precedence. Plus and open parenthesis should be computed. For example, id plus open, then inside the bracket should be evaluated first because of the highest precedence. Plus and close. Before closing, I have to evaluate plus because of that plus as highest precedence. Plus and dollar, and plus as highest precedence. Like that, we should be write the precedence relationship with the all. See, ID and ID, there is no relationship. ID and open. See, ID and open, I can't write. Between ID and open, there is an operator between that. Because of that, there is no relationship between ID and open for that one. Okay. Again, open and dollar. After opening, there should be an operator between that. Because of that, there is no relationship between open and dollar, and close and ID. See, close with 3. I can't write close with 3 because the computer, we don't know what is the operator. We normally multiplication, close with 3. But there is a relationship between that. You write empty. Close, close and open. See, close and open. Between that, there is nothing operator. That is also not old school. Okay, these are the some representation. I can now, next is sometime rare cases you'll be asking for, right? Precedence function. How can you write the precedence function for that one? Okay, there is a relationship between f of a and f of b. How can you write the relationship between the precedence relation table? The compiler using operator precedence parser do not need to store the table of precedence relation. That means the compiler will not store the precedence relation, but it store the to precedence function value as integer. See, we are writing this table. This table is not stored in the compiler. This table will be modified as a function. That function value should be stored like this. This is it. It will contain this table. The compiler will store this one. Okay, this is called operator precedence function table. How can it generate operator precedence function table? Okay, that is called precedence function. Instead of storing a precedence relation, we are storing as a integer value with function. For that, the table can be encoded by two precedence function f and g that map the terminal symbol to integer. Then we are using two functions, a and b are the two symbol. I am taking f of a is less than g of b whenever a is less than b. F of a is equal to g of b whenever a is equal to b. F of a is greater than g of b whenever a is greater than b. For this relation, then this is the function relationship. I can write it. Okay, to constructing precedence function, we are using these formula. I have to use it. This is the method. If in case asked, you should write the what is the construction method. Algorithm. Create a symbol f of a and g of b for each a that is terminal or dollar. That means I want to create a node like this, g of id, g of plus, f of id, f of plus. You can write any order, there is no issue. You can write all f of function here, all g of function here. For all the terminal, you should create a node, f of id, f of plus, f of star, f of dollar. See, I didn't take all input symbol. For the first problem I solved, id plus id star close. For that example, I written for that only I am taking a plus star id and dollar. Each and everything ended with dollar. Okay, you can write f of id, f of plus, and f of star and f of dollar. Or you can interchange value also. There is no problem in the diagram. But whatever you want comfortable, you can write it. Just I am writing g of id, g of star, g of plus, and g of dollar also. Okay, now for sake of the diagram should be simple. I am interleave those operator. Okay, this is called the first step. Create a symbol of f of a and g of b for each a, that is a terminal or dollar. Next, partition the created symbol into many groups as possible in such a way that if a is equal to b, then f of a and g of b are in the same group. Okay, I will tell you what happens that one. They create a directed graph whose nodes are group found in 2. Then I want to make a graph between A to B. How can I write in that graph? Edges. See, for any A and B, if A is less than B, assume there is a relationship between plus and star, there is a less than, then I want to write a edge between, place a edge from group of G of B to group of F of A. Or if case A is greater than B, then place an edge from group of A to group of B. Okay, I will show in the diagram what the step 3 indicates. Once you write all the edges, the next fourth step is, you see, if the graph constructed has a cycle, then no precedence function is exists. There is a cycle in that graph, then there is no relationship. But if there is no cycle, let f of a be the length of the longest path beginning at the group of f of a. That means each function f, I want to find out the longest path between the beginning of the terminal to end of my terminal. Always should be find the end of the terminal is dollar. Either it can be G dollar or it can be F dollar. It should be reach dollar, but the longest path. Then same thing, let G of A be the length of the longest path beginning at the group of G of A. Okay, let me start how to apply that algorithm. As the rules I show it, you should be first write the all nodes, whatever the operator should be have. I have only two operator. One is identifier, one is plus and star, then dollar I wrote it. Okay, now start write the edges. How to write the edges? If you want to write edges, you should be taken this precedence table. So you take the precedence table. Is there any edge between id to id? Assume this is an f and this is an g. F of id to g of id, there is no edge. No need to write any arrow mark. See, f of id to g of plus. What is there? F of id to g of plus is greater than symbol. F of id to g of plus is greater than symbol. Then I have to write then 3. F of id to g of plus, there is a greater than symbol. Because of greater than symbol, you should be write edge from f of id to g of plus. If in case less than symbol, then write an edge from g of plus to f of id. See the second one. This f of id to g of plus, I am writing greater than symbol. Okay, now I have to show one more. Next one. F of id to star, g of star. F of id to g of star. What is there? Greater than symbol. F of id to g of star. See, f of id to g of star greater than symbol. I am writing then edge from f of id to this. The one more is f of id to dollar, g of dollar, f of id to g of dollar. See, f of id to g of dollar is greater than symbol. Because of that, I am writing an edge from f of id to g of dollar. This one, green. The green line shows for the f function. For that function is over. Okay, now I am on to the second line. The second line is plus. From the f of plus to id. From f of plus to g of id. See that arrow. F of plus. See, f of plus to g of id. F of plus to g of id. There is a relation between f of id to what? See, f of plus. F of plus to what? G of plus. See. F of plus to g of id. See, f of plus to g of id is less than. Then how to write? From the g of id, I have to write the relationship. From the g of id to f of plus. Because of less than symbol, then I am writing g of id to f of plus. The same thing, next is f of plus to g of plus. F of plus to g of plus is also f of plus to g of plus. What is there? Greater than symbol. Then write an edge from f of plus to g of plus. Like that, you should be construct for all the nodes with respect to table. You will get an edges. After writing edge, I want to construct this table. While constructing this table, first you write in that plus id dollar, this one. You write two function. Now I want to find out what is the longest length between f of plus to the dollar. Find out, the first symbol is plus. Find the longest path between f of plus to the dollar. The dollar can be g dollar or f dollar. There is no issue. But should we take only the longest path? See, I am taking for the f of plus. F of plus can reach by g of dollar only one. There is only one edge count as a one length. One length. Is there any outgoing edge? Yeah, I have one more outgoing this side. G of f of plus to g of plus. G of plus to f of dollar. Then how many length? This is 1, 2. I got 2 length. Is there any outgoing edge from f of plus? No. Then the longest path between f of plus to dollar is 2. Because of that, I am writing 2. Now I can go for the star, f of star. Identified f of star. How many outgoing edge? 1, 2, 3. If you go with this one, the length is only 1. Then I can't take. If you go with this one, 1, 2, you get 2. If you go with this line, 1, then if you go 2 only. Or you can go next one, 1, g of star f of star 2, f of plus g of plus 3, and g of plus f of dollar is 4. Then the maximum length from star to dollar is 4. Now find out id. From f of id, there are options. How many outgoing edge? 3 outgoing edge. See, first one is only length 1. Second one is 1, 2. Third one, 1. You can go directly 2 or 1, 2, 3. I don't want that one. 1, 2, f of plus to g of plus to f of star. Okay, like that, identify the longest path. You can go anywhere, any number 3, but you have to visit all the nodes. F of id to star to f of plus to g of plus, and later find out the longest path between the operator. The same thing you do g of plus. Say g of plus. How many outgoing edge? Only one outgoing edge. Then the length is only 1. F of g of star. How many outgoing edge? 2. What is the maximum length? Either it go g of star or f of dollar is only 1, or 1, 2, 3. G of star, f of plus, g of plus, and f of star. There is the maximum. Like that, then f of dollar, there is no outgoing edge. You write 0, 0. Okay, this is called operator precedence function table. Okay, if you write function table, write this diagram and this. The exam will not get complicated input symbol. Always you will get a simple input. Otherwise, the diagram is very difficult to write it. Okay, now we can conclude. Thank you for